Usu. Hey, Samir on. Come here, sit down with me.
What are you doing, bro?
Oh no, this unknown fella sent me these 3 matrices and one of it contains a message.
Message.
Yeah.
So, do you know how to decode that?
I know by finding the inverse, but I don't know how.
Inverse, yeah. Don't worry, man. I got some friends to help you, but you've got to FaceTime, man. Can you do that?
Yeah, sure. That sounds like a good idea. Let's go.
Nice. Let me call.
My name is Sujawan and today I'm going to talk about how to find the determinant for K1. We can find the determinant for K1 by expanding along row 1. Positive 5 times 11 minus 3 times C12 plus 1 times C13 and negative 5 times C14, which we can get this one. And how we can expand this one along row 1 by covering up row 1 and column 1. We can use AD minus BC, which is 1 times 5 minus 3 times 5 to get negative 10. So we can find 19 by covering up row 1 and column 2, and we can find 23 by covering up row 1 and column 3. So positive 3 times negative 10 minus 5 times 19 plus 4 times 23, and it's the same way for all this metric. So we can find that positive 5 times negative 33 minus 3 times negative 11 plus 1 times negative 22 negative 5 times negative 44 to get 66, and determinant should be in the denominator, which is 1 over 66.
For C4 we begin with the negative. Three, 1, 5, 3, 5, 4, and 5, 1, 3, and we will get the answer 44. After we have found all the cofactors, we will get the C for the K1 is here. And then we need to transfer the C into C transpose. In order to find the C transpose, we need to change the first row into the first column. First row into the first column, so negative 33, 11, 52, 44, negative 66, 42, negative 6, 42, 33, negative 1, 8, negative 34, 66, negative 44, 22, and negative 44. After finding the determinant of the K1, we need to find the cofactors of the K1 by using this method. The first numbers of the column row 1 and column 1 begin with the positive, and then negative, positive, negative. And for the second row, we begin with the negative, and the third row begin with the positive, and the fourth row begin with the negative. After we have found the cofactors of the K1, we must multiply it with the determinant that we've got from the first, which is 1 over 66, and we will get the answer. So we will get the message of the M is here. However, the message cannot be decoded because it is in the negative form and also in the fraction form. We cannot get the message by using the whole number given. So there is no message in K1. After we have found the cofactors, we must multiply the cofactors with the determinant that we've got, which is 1 over 66, and we will get the inverse of the K1 is so this is the inverse of the K1. In order to find the message sent by Along, we must multiply the inverse of K1 with the P to find the cofactors of the first column and the first row, which is C11. We must draw a line on the first row and the first column, then write down the numbers 3, 5, 4, 5, 1, 3, and 2, 5, 5. Then from here, use the same method, which is 3 times 5 minus 15 minus 5, because this is begin with a positive, negative, and a positive back. Then 5 times 25 minus 6 and plus 4, 25 minus 2. Then we will get the answer equals to negative 33. For the C to 1, we begin with the negative, and from here we will get the C12, 3, 1, 5, 5, 1, 3, and 2, 5, 5. Since we begin with the negative, this is the big column. Here 3 times 5 minus 15 minus 1 times 25 minus 6 plus 5, 25 minus 2, and close the bracket, and we will get the answer 11. As for the C31, we begin the positive. We will get 3, 1, 5, 3, 5, 4, 2, 5, 5. Same method used, and we will get the answer negative 22. And for the C41,
now I'm going to show you how to find the determinant for K3. We can find the determinant for K3 by expanding along row 1. Positive 4 times C11 minus 4 times C12 plus 4 times C13 negative 4 times C14. And we need to expand this one by expanding along row 1, which we can done by closing row 1 and column 1. And by using AD minus BC, we can get negative 1. You can get 7 by closing row 1 and column 2. And we can get 11 by closing row 1 and column 3, which we can get we will do by positive 4 times this minus 4 times this, which is the same way for all the matrix. And finally, we can get negative 28. And determinant should be in denominator, which is 1 divided by negative 28.
Assalamualaikum. My name is Muhammad Adam and I'm going to explain to you how to find the inverse for matrix K2. So it is required for students to find the inverse of this matrix using ERO method. But this matrix cannot be inverse even using ERO method because it is a singular matrix, which means its determinant is equal to 0. So we can prove this by finding its determinant. So how do I find the determinant in this matrix? Is by covering up the first row and the first column and producing a new 3 by 3 matrix from. So after we have covered up the first row and the first column, we generate a new 3 by 3 matrix, and we have to multiply it with the intersection number, which in this case is 3, because we pick the first row and the first column and we have to put it in front. So this matrix will multiply by 3. So in this case, we have to alternate positive and negative terms. So for example, my first term here is a positive term, and then followed by negative, positive, and then followed by the last negative term. So for the second term, I use still the first row, but for this case the second column. So the matrix here is taken from here and here. So we do not take the numbers that are in the row and columns that we choose. So it's the same concept for the third and fourth, but alternating positive and negative signs. So after we have done that, the 3 by 3 matrix still cannot be calculated. So what we have to do in order to find the determinant is to further simplify this 3 by 3 matrix into a simpler 2 by 2 matrix using the same concept as above by selecting a row and a column. After we have produced the new equation with the 3 by 3 matrix, we need to further simplify the matrix so we can calculate it and find the determinant. This can be done by using the same concept as above, selecting a column and a row and using what's left in the matrix to find the numbers, to find the whole numbers. So in this case, what I did is 1 and 2 I multiply and minus with 4 times 5 here, and I subtract it with the first row and second column cover. In this case, the numbers are 3 multiplied by 5 minus with 1 multiplied by 5. So in this case, the intersection number for this term is 1, so I don't have to put a coefficient in the front. But for the third term, as you can see here, the covered number is 2. So what I need to do is to multiply the AD minus BC by 2, then I could calculate it as shown. Okay, for the first set of 3 by 3 matrix that is produced, what I got was 18 minus 10 plus negative 14 times 2, which is negative 28. And I have to multiply this whole thing by 3 because of the coefficient in the front of the 3 by 3 matrix. So what I get is negative 60, followed by the second, which is 14, the third set of matrix, which is 30, and the fourth is negative 44. So the final step is to actually find the determinant. This can be done by adding the numbers that we find from the 3 by 3 matrix. In this case, we still need to alternate the plus and negative signs. In this case, negative 60. This one is actually positive, but because the number itself is negative, so it becomes negative. So minus 14, so the number here is actually positive 14, so we have to alternate the plus and minus signs. We got negative 60 minus 14 plus 30 minus negative 44 will add up to 0. So by this I can deduce that the 4 by 4 matrix is actually a singular matrix and no inverse could be produced.
Okay, Busu. So I will teach you and show you how to know that if these K2 matrices can be used to decode the secret message. Okay, first we have to find the inverse of this. And you have how to find the inverse of this. You have to convert these matrices to these matrices 1 0 0 0 1 0 0 0 0 1 0 and 0 0 0 1. Okay, first what you have to do. Okay, look at me. I minus the row 1 with the row 2 and the row 1 only. Okay, look at the row 1. 3 1 3 2. I minus it with the row 2. 2 1 1 2. So look at this. 3 minus 2 equal to 2 1 1 minus 1 equal to 0. 3 minus 1 equal to 2. 2 minus 2 equal to 0. So, and this go on. Look at my second step. Row 2 minus 2 R1. Okay. Row 2 minus 2 R1. Okay. Look at this row 2. 2 minus 2 times 1 equal to 0. 1 minus 2 times 0 equal to 1. 1 minus 2 times 2 equal to negative 3, and 2 minus 2 times 0 is 2. And this step will go on. Will go on and on until you find the inverse. But as you can see, I use this step all the way, but I cannot find the inverse. Because of what? Because the determinant of these matrices that you just found is 0, right? So if determinant is of square matrix is 0, then the matrix is not invertible. So there is no inverse. Because of what? Determinant of matrix is 0. Its rows are linearly dependent vectors and its column are linearly dependent vectors. Okay. So that's all from me. Thanks.
Now I'm going to show you how to find the determinant for K3. We can find the determinant for K3 by expanding along row 1. Positive 4 times C11 minus 4 times C12 plus 4 times C13 negative 4 times C14. And we need to expand this one by expanding along row 1, which we can done by closing row 1 and column 1. And by using AD minus BC, we can get negative 1. You can get 7 by closing row 1 and column 2. And we can get 11 by closing row 1 and column 3. Which we will do by positive 4 times this minus 4 times this, which is the same way for all the matrix. And finally we can get negative 28. And determinant should be in the denominator, which is 1 divided by negative 28.
So for task 3, we have to find the inverse of K3 by using the adjoint method. So we have to find the cofactor for each number in the square matrices of K3. So first of all, I will show you how to find cofactor first row and first column. So first of all, delete the first row and then delete the first column, and then the number that still left, you take it out and make it like this. And then you have to find the determinant of cofactor first row and first column by using this method, which is the green color 4 4 2. We have to multiply each other, which is 4 times 4 times 2 plus with 2, negative 5 and negative 3. 2 times negative 3 times negative 5, then plus with negative 1 times negative 3 times 1. And then you have to minus it with you have to minus with 2 times 4 times 1. Minus with negative 1, negative 5 and positive 2. Minus with 3, 4 times negative 3. So after you calculate all of these, you should get 11. So after you calculate all the cofactor for each number, so you should get this pattern. And then after you calculate all the determinant for each cofactor, you should get this value. So since adjoint K is equal to cofactor transpose, then we should change, so we should change cofactor to cofactor transpose. So cofactor transpose is, you have to make first row to become first column, second row become second column, third row become third column, and fourth row become fourth column. In order to have, and then what you should do next is, you have to multiply 1 over determinant multiply with cofactor transpose, and then you should get this value. In order to help Busu to find the secret message that's sent by Alung, you have to multiply the inverse of K3 with matrices of P. That's all. Thank you.
So finally, K3 we can get this number, and 0 for A, 1 for B, and respectively, we can find that the first number is ASPE, RSYO, KNYA, AGRO, which is Asper short near agro, is the final answer.